Okay, so here we are on the website. When you open Blackboard, you get to the announcements page. If you look down here at datasets and click there, it'll take you to this tab, which if you click takes you to this website. And if you'll see, there are quite a few open source free datasets. What I mean when I say using a fake data set, what we're going to do is we'll use the numbers that are real numbers, but we're just going to change the name of the variable so that when you're doing analysis, you actually have real data that you can do analysis on and not just manufactured data. So what do I mean by that? All right, so if I go to examples of final projects from semesters past, I'm going to give you some examples and how to use it from that data set. So the research question is there a difference in the mean daily hospital blood usage by the shelter-in-place order? Now, it's not the greatest written research question, but it's fine. What they mean is prior to COVID lockdown, is there a difference between the usage of blood prior to lockdown and post-lockdown? So their null hypothesis is that the mean of the pre-lockdown is the same as the mean of post-lockdown, and then the alternate is that they're not equal. The analysis that we're going to use would be a paired sample t-test because you're using two measures from the same institution. So they are related samples, they're paired. So if I go to the data set, and I said, look at Arbuthnot. Arbuthnot is male and female births in London. So let's click there. And what this is from 1629 to 1710. So that's a long time ago. And what it was is that he used these time series data to carry out the first known significance test. During every one of the 82 years, there were more male christenings than female christenings. And as Arbuthnot wondered, we might also wonder if this could be due to chance or whether it meant that the birth ratio was not actually 1-to-1, male-female. Okay, so let's look. It says the format, right? It's a table data frame with 82 rows and 3 variables. So 82 subjects and on 3 variables. The year, boys, number of male christenings, and girls, number of female christenings. Now, it's the same when you go here. You have CSV, tab delimited, R construct, or R data. And if you click in here, you get to it also. So we're going to use a CSV file, which is a comma separated value file. We click here and it downloads and will open up with Excel, but it is not an XLSX file. It is a CSV file. And you can see we have the year, boys, and girls, and some numbers. What we're going to do is we're going to upload this data set into SPSS and just call this pre-lockdown and this one post-lockdown. Okay, so how do I do that? Let me pull up SPSS, which is here. It'll take a second for it to load, and it's probably going to load on my other screen. I'm going to go ahead and X this out because it's not easy for me to find it from my, when it's open, when Excel is open. So here is a blank data set, and I'm going to go to File, Import Data, and I want CSV data. Okay, and here it is. It's already there, so I've downloaded it a few times. I'm just going to click on Arbuthnot. I'm going to open it. It's going to take a second for it to load. Once it shows OK, I'm going to click here. Everything always pops up on my other screen, but that's all right. All right. Now, let's go to Data View. You can see everything's loaded. We're going to rename boys and girls to pre-lockdown and post lockdown. And we're going to go ahead and run a paired samples t-test. So I'm going to go to compare means. We come here and go to paired samples t. I'm going to bring pre-lockdown over. I'm going to bring post-lockdown over. Now in the newest version of SPSS, we now have estimates of effect sizes. It'll just give it to us. And we're going to say OK, and you'll see that my output is in APA format. I'm going to show you how to tell your computer to do that. You go to Edit, come down to Options, click on Options, come over here to Pivot Tables, and you'll see System Default is what we're used to seeing. If I click APA times New Roman, I get that, and I'm going to do that, and it'll give us output that looks like this. Either way is totally fine, but for publication or for your dissertation or thesis, you might want to use APA format. So, all right, now these boys and girls data are now pre-lockdown, post-lockdown, totally fake, doesn't matter. We're just going to use these data to approximate for that research question. Okay, so let's see what we got. So pre-lockdown we have 5907 and post-lockdown we have 5534. We get correlations when we do a paired samples t-test, and we didn't ask for it, but it needs to do it to calculate these confidence intervals. So it's just kind of bonus output that we get. All right, so we can see that the mean difference is here. Our t-statistic is very large, 21.4. Degrees of freedom 81, and then we get this one-sided and two-sided p, which is a new thing SPSS is doing now. It's giving us these two options. We're pretty much always going to look at two-sided p, and so you can see that both are highly significant. And then here we get our Cohen's d. You don't look at the standardizer, we're going to look at this point estimate, and we get 2.4. Okay, so we can see that according to that this data set, which is fake, we understand that, but we're going to use these output to report the findings for this research question. All right, so another example, we have, is there an association in red blood cell and platelet transfusion reactions between pediatric and adult population? They ran a chi-square test of independence to determine whether there's an association between categorical variables where they have age as categorical and red blood cell and or platelet transfusion reaction is also categorical. So we have, they're either peds or adults, or they have a red blood cell reaction or a platelet reaction. So the null hypothesis is that there's no association between age and reaction, and there is an association between age and reaction. And so what they do is they have this contingency table, and they can just plug it in like we would normally do. And if you have a research study that you've read online and they give it to you as a contingency table, you can just plug in any numbers that you want in here and then use that. Or you could even use the data that are in the research study, and maybe they have more information than you want, but you could just plug in those numbers, put it into SPSS, and recalculate it. I don't want to see any kind of published figures or tables, but you can use their data and put it into SPSS and rerun it as though it was your own. All right, so here's another one that's going to be another paired samples t-test. The purpose of the study is to evaluate the effectiveness of the PGD test in reducing number of platelet discards and reducing cost for the transfusion service at Holy Cross. So this particular research question is there a difference in number of platelets discarded by the PGD method? And they're looking at 2018 versus 2019. Null hypothesis, they're the same. Alternate hypothesis is that they're not the same. Okay, and then here we have one, same thing, another paired samples. We have lots of paired samples t-tests, especially around the COVID-19 lockdown incident. Okay, and then another one, this is a different one where we're going to look at an independent samples t-test. So the purpose of this study is to determine if residential altitude, high versus low, of plasma donors significantly affects immune response. And they use the measurement of the quantitative anti-D flow by flow cytometry. So the question is there a difference between residential altitude and immune response? And so the null is that there is no difference, and the alternate is that there is a difference. Okay, so let's go look at exam grades. So let me minimize this and go to the website. Let me go back. And let's look down here at exam grades, right here. Exam grades and course grades for statistics students. And so we're going to look, it's a data frame with 233 observations. We have sex, we have exam 1, exam 2, exam 3, and course grade. Fine. So we're going to download the CSV file. Okay, let's take a look at it. Alright, so we have course grade and exam grade and exam grade, and so, okay, so let me upload that into SPSS. I'll pause for a second. I'm going to open a new data file. Okay, of course, it does it over here. Alright, I'm going to go to open, I'm going to go to import CSV. Alright, now we have exam grades. Open it. Takes a second. Okay, we say okay. Just go to the data. Oh, it's over here, always. Okay, so we have our data view, looks just like it did in the Excel spreadsheet, variable view. So let's go back to our example, and we're looking at residential altitude and immune response. Okay, so what do we need here? We need a continuous variable for the immune response and residential altitude, high versus low. So we need a two-level categorical variable. So this is, okay, we've got the right data set up. We've got man and woman. All right, even though these are statistics grades, we're going to use this two-level gender variable as our grouping variable. We're going to say man is 1 and woman is 2. And so what we'll do is we'll highlight that column. We'll go to edit. We'll do replace. Let's do man. And I had tried it with words, but it doesn't like it when I go to do the independent samples t-test. So we're just going to use numbers. We're going to say man is 1. Say okay. And then we'll say woman. Whoops. Woman is 2. Replace all. Okay. Okay. Go to variable view. Go to sex. We're going to go 1 is high altitude and 2 is low altitude. Say okay. We're going to change that to not sex, but altitude. And we're going to change this course grade to immune response. Okay, good enough. Okay, so we'll go to analyze, compare means, independent samples t-test. I've already got it set. Let's redo it. Altitude, 1 is 1. 2 is 2. Continue. My immune response is my test variable. Everything's already highlighted. Effect size is there. We do it. We can see that the mean of 1 is 71. The mean of the second one is 74. So high and low. You can see that when we look at this, the Levines, we do not want this to be significant, so it is not. So we stay in this top row. This is a pretty small t statistic. Degrees of freedom of 231. One-sided is close to significant, and two-sided is not significant, but we're pretty much going to just look at the two-sided p. It's very unusual to have a one-sided p, and actually it's easier to find significance when you have a one-sided test. But we're going to look at the two-sided, and we see that it's not significantly different. Okay, briefly, I just want to take you back to the front page of the Blackboard site. Again, that's data sets. Click here. I will have the video that I'm making right now posted here. Go to data sets for final projects, and there are all the data sets. Take a look and see which ones will work with you. If we need to meet, we can do that via Zoom. Thanks.